Hello. Centre of mass, centre of gravity. What is the centre of mass? Well, the centre of mass of an object is the position where all its mass seems to act. And we use the term centre of mass, centre of gravity interchangeably. If I have this ruler, then its centre of gravity, centre of mass, is where it balances. And there we have it. If we want to determine the centre of mass of a lamina, a sheet, then we'd use a plumb line like this. Now, what is a plumb line? My plumb line is just a string and a piece of blue tack. Romans used devices like these to get the vertical when they were building their buildings. Builders still use them. And of course, the Latin word for lead is plumbus. They use a bit of lead at the end rather than blue tack. So what do? Well, I take my lamina and I put it on the pin point, make sure it's free to move. I put my plumb line on there like that, and I mark the position of the plumb line, and then I draw a line. And I then suspend it from another point and do the same thing again. I have two lines that cross, and when I put my finger at that point, we can see that that is the balance point. That is the centre of mass. Now, if I have a lamina, a card that is shaped like this, an L shape, and I do the same thing, and I have done the same thing, I get two lines, and the intersection, curiously, is somewhere in the middle. My centre of mass, my centre of gravity, is about here. But when I do the pole vault, as I don't laugh, when I go over the bar, my centre of mass might actually be somewhere below my tummy. And indeed, my centre of mass might go under the bar. Okay. Stability. And how does that relate to centre of mass and centre of gravity? Well, a car like this ideally should have a low centre of mass and a wide base. That gives good stability. A double-decker bus, a loaded double-decker bus, might have a higher centre of mass, centre of gravity, and it would have a reasonably wide base and hopefully would be very stable. Indeed, tilt testing is done on buses, or has been done on buses, in the case of this old London bus, to determine how stable they are. Now, a block of wood like this, how do I determine its centre of mass? I can draw two diagonals, and where the diagonals intersect, the centre of mass should be within the block at that point. Okay, let's just look at this for a moment. This bottle has a fairly stable position. We say it's in stable equilibrium, but if I tilt it upside down, put it upside down, it's in unstable equilibrium. It doesn't require much of a force for it to fall over, and at the same time for its centre of mass, centre of gravity, to fall with it. If I put the bottle like this, I can push it, but we say it's in neutral equilibrium because its centre of mass doesn't rise or fall as it moves along. So, can we go a little bit further with this idea of stability? I have here my tilt test platform, and I have a cunning mechanism from which the angle of the dangle gives me the angle of the slope. It's another mini plumb line. Now, I have a block of wood here, solid block of wood. If I put it against here, now I've marked the centre of mass, centre of gravity, and I have a plumb line suspended from there. Now, the theory, of course, tells us that if the centre of mass goes beyond this vertical, then the whole thing will tilt over. So let's just try that. And if we look at the pendulum, look at the plumb line, we can see that round about now, there. At that point, the centre of mass was over this edge, vertically beyond, just beyond that edge. If I take this block of wood again, I think we'd agree that this has a much lower centre of mass. And let's put it on the tilt test table again. And yeah, it's going to a much larger angle before it tilted over. Now, what have we got? Let me show you a puzzle. This particular bit of wood, I can put it onto a wine bottle like this, and it seems incredible that it just balances like that. But if we think about this, the base of this wood is here, and the centre of mass of the bottle of wine should be somewhere above that base. If it wasn't, if we had changed the position, if it wasn't, then it would tilt one way or the other, which could be catastrophic. Now, just before I finish, I'm going to leave you with a challenge. And the challenge is this. I can take this old retort stand and I can certainly find its centre of mass, centre of gravity. I could mark it. Now, with a 200 gram mass, my challenge to you is, how would we actually determine the mass and then the weight of this whole retort stand? So that's a challenge to you. This has been Fez Physics, and thank you very much.